Right, pre-cal academic, Thursday, December 8th, the Solemnity of the Immaculate Conception. Okay, so here's the compound interest formula. You guys should have learned this at the beginning of Algebra 2. But what this says is, so I'll say P is called the principal. Okay, P is called the principal, or that's the initial amount invested, the initial amount in account. All right. Here's your life application math class for you. There you go. Okay, not going to retire without compound interest. Okay, A is going to be the final amount in your account, final amount of money in your account. Okay, so if you invest P dollars in a compound interest account, okay, to get the final amount, you multiply it by 1 plus R over N to the NT. R is the interest rate. That's your interest rate, okay? And N is the number of times the account is compounded.
Under this interruption, will all choir students please head to the west?
Per time period, usually it's per year.
Thank you.
All right. All right, and then T is the number of time periods that have passed. Usually it's the number of years. Okay, maybe I'll put the camera on. All right, so there you go. So, so R is the interest rate, N is the number of times it gets compounded per time period, okay? So here's an example, okay? If your time period is years, okay, so if like a problem tells you your account gets compounded monthly, okay, how many times per year is your account going to get compounded? 12, right? So you plug in 12 for N, okay? So what this does is it just scales the interest rate based on how many times it gets compounded, okay? Because if you have the full interest rate compounded every single month, like you'd have it'd be ridiculous annual growth rate.
Be a nice annual growth.
Be a very nice annual growth rate. One that you probably couldn't get without an incredible amount of risk. Okay, so Trevor Lawrence, all right, invested his entire signing bonus in Bitcoin. He lost a lot of that, unfortunately, but he's still a multimillionaire. It's probably worth more than any of us ever will be. It's all good. It's all good. You can't take your money with you after you die, so. What's that? Heaven cash. That'd be awesome.
What would be religious currency? Just give me a good bread. Be like, treat your Christian
Indulgences. All right, so let's do this first problem here. How long will it take for an investment of $1,000 to double if the bank pays 2.5% interest compounded quarterly? Okay. Okay. So let's do this in years. So T, we're gonna do T in years. Okay. What's the question asking us? They say how long, right? So we're going to be solving for T, okay? All right? And we can just pick the units for T, right? We could do T in months if we wanted to. We could do it in seconds. That'd be a really hard math problem. So let's just do it in years. Okay. What's my R? The R is pretty simple.
2.5.
I think you do it. Yeah, you do it by what would we plug in? If it's 2.5%, we plug in 0.025. Yeah. Yep. So that's R then. Okay, so it's compounded quarterly. So what's quarterly mean?
4.
Every 3 months, right? So it's going to get compounded 4 times a year, okay? And then it's kind of weird. I guess what's P? What's P going to be? It's actually not kind of weird. P is going to be 1,000, yeah. What'll A be, though? What will A be? If we're waiting for it to double, we're waiting for the final amount to be what? 2,000. 2,000. Hey, who won the wrestling?
I think so. I don't know.
It's all
I only want to.
It's all good. Okay. So let's just plug these all in. Okay, I'm going to plug in 2,000 for my A. I'm going to plug in 2,000 for my A. For my P, I'm going to plug in 1,000. Okay, we following so far? For mine, then I have 1. It's just a 1 right here, okay? It's always 1. 1 equals 1. Okay. 1 plus R. What's my R? It's 0.025. All over N. What's N for? And then to the T. So we're going to solve for T, okay? All right. Oh, yeah, you're right. 4 times T. Thank you. All right. All right, the hardest part about compound interest is a lot of people don't know how to plug it into their calculators. Yeah, what's up? Yeah. Okay, so we're solving this for T, okay? We got to get T by itself. We got to get T by itself. What do you guys want me to do first? What do you guys want to do first? We got to start bringing stuff. We got to start bringing stuff over to the other side of the equation. So what can we do? Divide by 1,000. Yeah, it's kind of that's a good call. Let's divide by 1,000. So 2 equals. Okay. Usually it helps to simplify things. Okay, so can we simplify what's in here? Yeah.
Why can't you just do the thing that we did where you plug in the lines? So you do 2,000 for the line.
Oh yeah, like solve it graphically?
Yeah.
You could do that.
Find the intercept.
You could do that, yeah. You could do that. Yeah, I'm gonna show you guys just how to do it with logs and the sphere. We already know how to solve by graphing, so let's like learn. Yeah. Okay, so I'm gonna combine these on my calculator. So I'm gonna do start with a fraction here, guys. Do 0.025 divided by 4, and then do a plus 1. Okay. You should get 2 equals 1.0. Thank you, 1.00625, and that's still raised to the 4t. 4 times t, not 40. Okay, I don't know why it just stopped screencasting, but it did. All right, cool. Good stuff, good stuff. Yeah, so you could do a graphical at this point. You could plug in 1.00625 to the 4t for like your y1, and then you could plug in 2 for your y2, and then see where they intersect. You could do that. Okay. Let's do this with logs. How do you break a t out of an exponent? With a log. Yeah, you do a log. Okay, so it's going to be log. I don't know why that's devastating, but. Okay. So these cancel, right? We have log base 1.00625 of 2 equals 4 times t, or t equals 1/4 times log base 1.00625 of 2. Okay. All right. So now we have t by itself. We just got to plug all this into our calculator, right? How do we do that? How do you do log base 1.00625 in your calculator? What's that? Math, alpha math. Oh my gosh. Oh yeah, you can do that. Yeah, so Elise just said you can do this one of 2 ways, okay? If you hit math, and then alpha, then math, it pulls up the log base. You can just put in 1.00625 of 2, right?
Where's the alpha button?
It's the green one. So math and the green button, then math again.
Oh.
Yeah. You can do that, or you can do change of base. So how do I do change of base? I do log of 2 divided, so log of whatever's in the parentheses over the log of whatever's in the base. 1.00625. Yep. So then that will give me, so I got 111.2497, but remember, t is equal to 1/4 of that. So it's 1/4 of the result in my calculator, so I just do divide by 4. Okay, that gives me 27.812, or in 28, let's round up to the nearest year. So in 28 years, so about 28 years. Okay, if I'm trying to retire, I'm probably not going to be like, okay, like I'm at 27.7 years, I only have 1/10 of a year left, so I retire. It'll probably just be like 28 years. Probably retire at the end of the fiscal year for tax purposes or something. Okay, so 28 years. How are we feeling about that? Not too bad? Okay, good. All right, now they're asking what for the second question? How much, right? How much will be in the account? Which variable are we going to be solving for? A. Yeah. Going to be solving for A, okay? So A, we don't know what A is, so we're just going to leave it as A, okay? What's my P? 1230, thank you. All right. What's my, so then we have 1 plus, what's my R? What's my R? Yeah, so I take this percent they gave me and I move the decimal place over twice. Right, so it's 0. Point what? 0.3125. Then how many times a year? So right, they gave us the time in years. Okay, so how many times a year am I getting compounded if it's compounded monthly? 12. 12. Okay. What? Oh, okay. If it's nothing I can control. All right. And then I got to put an N. I got to put the N up there. What's my T? 10, yeah. Okay. This is a good example. Okay. So then we don't have to do any graphing, right? You can just punch it onto your calculator, right? But it can be confusing because a lot of students can get like all the parentheses and stuff wrong. We did this at the very beginning of the year in Algebra 2. And like a lot of people got the parentheses wrong and everything. Okay? So let me write this down on the board so I can remember what to put in my calculator. And then 12 times 120, okay? You guys are cool if I simplify that to 120. Okay, so in general, so when we're doing these, when you're doing this in your calculator, you guys, it's best to start with this fraction, okay? Start by putting the fraction in your calculator. We want to hit enter as many times as we can in our calculator, okay? That's going to help us get our order of operations correct, okay? So I'll show you guys how to do this. Okay, we're going to start with the fraction, okay? So we're going to do .0.0312225 divided by 12. Okay, we're going to start with that fraction. Okay, hit enter. Okay, hit enter so it saves. When you hit enter, it's just going to save that fraction. What am I going to do now? I'm going to do plus, so it'll be answer plus 1. Okay. Enter. Okay, so start from that fraction, then move outside. What do I want to do now? Am I going to do times 1230 or raise to the 120 first? So what does order of operations tell me to do? So do exponents or multiplication first. Yep. So now I'm going to do 2, so caret to the 120. Okay.
Well, I thought it was 12.
What? It was 12 times 10 in the exponent, yeah. Okay, now I do times 1230. Okay, there's my answer, $1,680.53, 1680.53. Okay, So it's not too hard to plug the numbers in that example. It's just, it can be a little tricky to put it in your calculator, okay? So start with the fraction, put the fraction, hit enter. Oh my gosh, this is actually really annoying me. Start with the fraction, hit enter, do a +1, then do your exponent, okay? So start with the fraction, Can we follow that? Simple enough? Not simple? Okay. Here we go, this one. There's no answer for this in the notes. Population of 450 geosites. Does anyone know what a geosite is? So my only question here is like, these notes are they're all about compound interest, but like in my mind, this would be an exponential problem. So let me see what geosites are, and we can geocities. No, I want geosites. Hashtag geosites. Okay. Yeah, we're just gonna skip that because I don't know what a geosite is. So. Yeah, it would probably be an exponential problem, which we did that, right? We'd be solving for t here. Okay. It'd be an exponential, so f of x equals a b to the x, okay? So how long would it take for the population to double? It'd just be, you could plug in whatever you want for a, just plug in 1, and then we'd plug in 2 for f of x. So just the final amount is twice the initial amount, okay? You see that? A is our initial amount, f of x is going to be our final amount, okay? So just, as long as f of x is just twice of what you plug in for an a, you're good. Okay, and then the growth constant is 0.123, so what would I plug in for b? It'd be 1 plus 0.123 the x. Okay, so 2 equals 1.123 x, okay? And then do log base 1.123 of both sides. So it'd be x equals log base 1.123 of 2, or log 2 over log 1.123. So 5.9, again, another reason I don't really like this problem.
What do you do with the 450?
Yeah, I don't know what the units is. Years, what's that?
What do you do with the 450?
Oh, I guess it should have been 450. I should have plugged in 450 here and then 900 here, but yeah, I'm not a huge fan of this problem, so let's just move on. All right. Talk to Ms. White about what's going on there, because it doesn't even have like a unit for time either. So can I move on to 4? Okay. How much do I need to deposit in an account paying 4% interest compounded continuously if I want to have $35,000 in exactly 10 years? Okay. So this is a slightly different formula from the compound interest. So this is compound interest right here. So let's make sure we have these straight, okay? Compound interest is right here. Continuously compounded interest is a little different. Does anyone know the continuously compounded interest? Okay, it's okay. This is called the PERT formula, okay? So the final amount in my account, so A is still the same thing, like all the variables are still have the same meaning. But the final amount in my account this time is going to be the principal, okay? And then instead of multiplying by all this fancy stuff over here, I'm going to multiply by e raised to the r times t, the rate times your number of time periods that passed, okay? we don't need to worry about the number of times it's getting compounded per time period because we're getting compounded continuously. Every single time we get compounded continuously, okay? So the n is kind of the same in every single one of these problems, so it doesn't show up in the formula. So, yeah. So it's just rate times e to the p, e to the rt, okay? That's important. Circle that, box that, star that, sign your name next to it, okay?
Wait, what's the like name for it?
Oh yeah, sorry. Should probably. Continuously compounded interest. All right. So what's going on here then? So what's my A going to be? I guess what are they asking for? What are they asking for? How much do I need to deposit? What's that? How much do I need to, how much do I initially need to put into the account, right? So they're asking for P, asking for P. Okay? Okay. So what's my A then? What am I going to plug in for A? What's the final amount there? $35,000. Okay? That equals P. We don't know what P is, so we're just going to keep it like that. Then E is just E. Okay? What's my R? 0 point, what's that? So it's 4% as a decimal is 0.04, right? Yeah, so it's going to be 0.04. So this time, you don't have to worry about the 1 here. It's just 0.04. And times 10, right? My T is 10. Okay. All right, then you just plug and chug in your calculator, okay? So, how do we want to do this? How do you guys want to do this? Do you want me to divide both sides by this E part first, or do you want me to put the E in my calculator, like change it into a decimal? What's that? The latter? Okay. Okay. So let's plug this in. Okay, so it's going to be E to the 0.4 times 10. So does people know where the E button is? Okay, it's going to be, here's E. You have to hit the blue, second E. Then caret to the 0.04 times 10, okay? And then I'm going to hit enter. That's 1.492. Okay, so this becomes 35,000 equals P times 1.492. Okay, now it's an algebra 1 problem. Okay, so you just divide both sides by 1.492. P equals, what's 35,000?
2, 3, 4, 5, 8.
Thank you. How many cents?
45.
45 cents. Okay. All right, so there you go. Yeah. All right. How are we feeling about this stuff? We're feeling okay about this? Okay. Good stuff. All right, Miss White, skip these 5 and 6. I think I might as well, actually. So let's go down to 7 and 8. 7 and 8. Okay. So here we go. Which formula am I going to use for this, first of all? Am I going to do continuously? Is it compounded continuously, or is it compounded some other rate? It's compounded monthly, so I'm going to use the compound interest formula, okay? Okay, what variable are they asking me for? A. They want A. Okay, so we're going to write A. We're just going to leave it as A for now since we don't know what it is. What's my P? 555, right? That's the initial amount we're putting in. Okay, and then 1 plus, what do I plug in for R? 0.035, yep. And then if I'm compounded monthly, and I'm asking, and my T is in years, my time is in years, and I'm compounded monthly, how many times a year, or per time period, am I going to get compounded? Yeah, 12. Okay, and then 12 times 12, right? We're just plugging in N and T. Okay, so again, how do we do these in our calculator? What do we plug in first? This is important. You need to make sure you guys know how to do this. Plug in the fraction first, okay? Start plugging in the fraction, okay? So I'm going to do that fraction first, okay? Then hit enter after that, and then I do a plus 1. Okay, I do my exponent next or my multiplication? Exponent, yeah, so it's going to be raised to the 144, because 12 times 12 is 144. Hit enter again. The more times you hit enter, the more likely you are to get the problem right, okay? So hit enter after each step, and then we multiply by 555. Okay, so we're going to have $844.17. All right. Can I move on to the next one? Not too bad. 8. What interest rate compounded continuously will be required to end up with $1,000 after 3 years if we initially put in $890? Okay. Which formula am I going to use? Am I going to use my regular compound interest, or compounded continuously? Continuously, right? They say compounded continuously. Okay, so we're going to use this formula. What are they asking for? What variable? Which variable are they asking for? Yeah, so we want R, right? We want R. What's my A? Yeah, it's going to be 1,000, right? It's the amount of money I end up with. It says I end up with $1,000. What's my P? $890. Okay, and then E is just E. R we don't know, right? We don't know, but what's T? 3, yeah, so it's to the 3 times R. We just leave R as is. Okay? How do we go about solving this? So we want to get E by itself first, right? So we're going to divide by 890 on both sides. Okay, I get that, around to the nearest 10,000th. All right, and how do we break our R out of the exponent? Do the log of both sides. Yep, we do the log of both sides. Okay, so an ln is going to cancel with my E. We're going to have 3R equals that log there, or we divide by 3. Okay, so R equals ln all over 3. Okay, you guys want me to show that on my calculator? Can you do it on your own? Should be able to just ln 1.1236 divided by 3. So the R that I got out of my calculator was 0.0388. Okay, what is that as a percent? Going back to percents. So it'd be 3.88%. That's pretty safe. Annual interest. All right. All right, you're just going pretty safe there. Doing like I don't know a ton about investing, but you're just playing it safe. Doing the large cap stocks. Yeah, what's up? Yeah, we can. All right. Cool. So there's another concept we have to learn about. Oh, okay. So then the other financial math we're going to talk about is annuities. Annuities, yeah. Do you guys do annuities in Algebra 2? Okay. How do you know about annuities? Okay. Yeah, so annuities. All right. So here we go. Here's the equation here. Okay. So FV is future value. That's like your A. So let me write this on the board. So that's like your A there. It's your final amount. So A equals 4. So the difference between, what's the difference then? So A is going to be our final amount. R is going to be like our regular payment. That's the regular payment amount, okay? And then I here, that's not the square root of -1. That's giving me my interest rate. Right. And then the N is the number of times you pay the annuity. Okay. So an annuity is a little different from like the problems we've been talking about today, right? So in the problems we've been talking about, you put in a principal, right, and then you just let it grow, right? This one, you're making regular payments to, right? So this would be like a retirement account, right? So you have money taken out of your paycheck, put in your 401k, or your 403b, or your Roth IRA, okay? All right, or your mutual fund, okay? So this is something we're making regular payments to, okay? So some of the money, right? Some of the money, what's different here is the money that we put in at the beginning, right, is going to have more time to grow than those payments we make later, okay? So it's a little different from these two forms. It's a little more complex, okay? But again, I is going to be the interest rate per compounding period. So it's not necessarily the yearly interest rate. It's just however much, it's whatever rate you get like per compounding period. So it's a little simpler. It's more like simple interest. And then N is the number of times you pay. That's the total number of times you pay the annuity. Okay. So we got 1 minute. Let's just maybe stop there. I'll just introduce it. Okay, so we know where we're sitting.